I don't want to give you the impression, though, that it's all roses. Increased energy consumption is not without its problems. In this section, we're just going to pay a little brief tribute to the deleterious effects of increased energy consumption. Negative effects of energy consumption are going to be primarily related to the side effects of extracting the energy resources from the earth. So we got to take it out of the earth, and there's negative side effects associated with that. The negative side effects of the emissions of the pollutants and the greenhouse gases that are emitted when we combust the fuels that we typically use to provide electrical energy. And then also on the impacts of the local environment at the site of the power plant and other electrical infrastructure that we use to convert primary energy sources into electrical energy, and that we use to transmit the energy from the power plants to us as customers. We've got a couple examples. It's not exhaustive. It's just supposed to be illustrative of some of these negative effects. So the first that I'd like to talk about is the process of mountaintop mining or mountaintop removal. This is a practice used in the coal industry in which surface mining is used to remove buried coal seams. And basically what they do is they have dozers, they come in, they cut off the tops of the mountains, they expose the coal seams, then these dozers mine the coal, or the other equipment actually drills out the coal, and then they carry it out in buckets, and then they try to take the land that they pushed away, and they try to just kind of push it back and then reform the top of the mountain. Well, that isn't the most successful. The removed land is kind of terraformed up there to kind of approximate that original contour, but critics of this practice of mountaintop mining, they cite the physical alteration of the landscape as a major problem. They've documented just massive amounts of groundwater contamination because your pollutants are getting out. There's impacts on the biodiversity. Clearly animals and plants, species all lived here. That also has impacts on the forest productivity. And there's also, a lot of times, while these mountains are often in rural areas, people do live around them, and so there's a good potential for human health impacts, and all of these are kind of major negative impacts. To kind of illustrate this point with a photograph, what we have here is a picture from a NASA Landsat satellite taken twice of the same location, one in 1984, one in 2009, of what's called the Hobbit Mine. This is in West Virginia, so not too far from here, 6 to 10 hour drive from here, Purdue, New Albany. And so what this is showing is the massive amount of deforestation and rerouting of the landscape, particularly the watersheds, due to this mine, right? So the coal companies came in and they basically terraformed the earth, and there are definitely some negative impacts, right? We've lost some trees, the streams are much wider, a lot of times there's impacts to this forest productivity and biodiversity. And I mean, you can just look at it and you can see that there is an impact, right? The next commonly cited impact is what we would call greenhouse gases. The anthropogenic or human-caused emission of carbon dioxide is primarily the result of combustion of fossil fuels. So that's been well proven. Most of the anthropogenic emission of our carbon dioxide comes from us burning coal, natural gas, and petroleum. And many scientists, or the majority of scientists, have agreed that this is the primary cause of what we now call modern global climate change. This is just a graph, not of climate change, but instead of energy-related CO2 emissions, historical and predicted, coming again from the Energy Information Agency. This data came from 2011. So the US EIA predicts worldwide emissions to exceed 44 billion metric tons by 2035. And interestingly, the majority of these increases is in non-OECD or the Organization for Economic Cooperation and Development, I believe, what does OECD stands for? OECD, think of that as industrialized nations, and non-OECD, think of that as, kind of like the other aggregate. So it's interesting, right? Most of the growth, the projected growth in these energy-related CO2 emissions is not coming from the United States, not coming from Britain, not coming from Japan, not coming from Germany, although there is some growth there, although it largely levels out or is projected to level out. But I mean, compare it to these other countries. So who are these people? Why are they putting out so much carbon dioxide? Well, they're doing the same thing that we did 50 years ago in the industrialized nations. This is India, this is Taiwan, this is Malaysia. This a big contributor to this is going to be China. And we could add on to that Brazil and Argentina, right? What's happening here is that the great rises in middle classes are demanding electrification, and how they're meeting that is largely with the same technologies that we used, 70 years ago or 80 years ago. These big coal-fired power plants, in other cases, natural gas-fired power plants. There's just a huge thirst for energy in the developing world, and to get it cheaply to the masses, they're going to provide it with fossil fuels when they're available. So there's going to be competition for this resource, and there's also going to be emissions of these greenhouse gases. Two large challenges that are going to continue to face anybody who decides to go into the electric power industry over the next, I'd say, 50 to 100 years, is going to be increasing competition for the resources and this emission of greenhouse gas worldwide. So, hey, why do we want to build coal-fired plants and natural gas plants when we can just build wind turbines and we can build solar farms and things like that? Well, technically there are some problems with just building solar farms and wind farms, which we'll talk about in this class too, but there are other problems that are just a little bit more practical. So, if we want to connect those solar farms and those wind farms that are built on ridges and out in the desert southwest to us, the people who use electricity, we need to put in some electrical transmission infrastructure to deliver that electricity to the consumers who are located usually hundreds of miles away from these power plants, or these renewable energy sites, or whatever you want to call them. What we call this is electric infrastructure, and as you can see in this picture, it requires an ROW, or a right-of-way. This is the spacing around electrical infrastructure that has to be set aside for the transmission line and associated facilities to provide a safety margin between this high voltage equipment and any of the surrounding structures and vegetation. Clearly nobody wants to live here either. You don't want to live next to this structure, and probably if you're an outdoor enthusiast, that's not where you're going to choose to go hiking or fishing or whatever it is that you enjoy to do outside. So there are these negative effects of these right-of-ways. The width of one of these right-of-ways can range from 50 feet up to 175 feet or more for lines that operate at greater than 500 kilovolts, which is what we're showing here. And often such installations are adamantly opposed by communities and special interest groups because they have an impact on the local environment, and largely because they have an impact on property values. This phenomenon is so widespread it gets its own name. It's called Nimby, not in my backyard, right? I want you to build that wind farm, but not near my house. I want you to build that wind farm, but don't run the transmission cables through my property, right? Well, they have to go someplace. So this is another challenge. And another negative effect of the fact that we have electrified the United States is if you drive around, there's all this infrastructure that poses kind of aesthetic issues, and it also can be dangerous. You don't want your kids playing around this, right? They could maybe shock themselves or something like that. So while electrification has really been, I would say, critical to the United States' success over the last 200 years, we do have to consider that these engineering decisions do have impacts on society that are not always positive. And our role as the future engineers who are going to be controlling, upgrading, and designing these systems is to really decide how in the future we're going to choose to best balance the economic benefits that come from increased utilization of energy resources and some of these negative impacts such as quality of our environment, the aesthetics of our environment, and our personal safety. So that's the end of the lecture. Thank you very much.